Okay, here we're going to use the directional cosines to calculate the force resultants for any 3D force. All right. So remember that we break it down into a theta. So our theta x is from the actual force itself to the x component, and so on. So angle theta x, theta y, and theta z define that. Now remember, if you only have two of these directional cosines, you can derive the others based on the equation we reviewed earlier, which is cosine squared theta x plus cosine squared theta y plus cosine squared theta z is equal to 1. So as long as you have two of these directional cosines, you will be able to derive the others. And quite simply, we just break it down using the law of cosine, and we can solve for that. So the cosines for of theta x is equal to fx over f. Solving for f of x is equal to f times cosine of theta x. And cosine of theta y is equal to the fy divided by f. And so solving for the force y component is force times cosine theta y. And cosine theta z is equal to the force component z divided by f. And solving for f sub z is equal to force times cosine of theta. And therefore, there we have all the equations necessary to derive that. The next video is going to go over using spherical coordinates, which are a little different and a little more involved, because sometimes the information you're given aren't related to these particular cosine angles, and that one will use spherical coordinate systems.